All right, guys. All right. Welcome to Frank Teaches MLOps. Yeah, my lovely viewers. Yes, guys. So today's video, we'll be looking at developing machine learning model. Yes, we've come to the most interesting series in this video. All right. The most interesting video in the series. The most interesting video in the series. All right. Developing machine learning model. All right, to make predictions. Okay, great, guys. Great. Now, to help us in this workflow, or in this process, okay, um I'll be using what I'll be relying on machine learning life cycle. All right, so let's look at the machine learning life cycle. Machine life cycle. All right, so great. So to help us, let's look at what the machine learning life cycle. So I'll be using the machine learning life cycle. What that means is that I'll be coding each of the cycles, each of the stages in the machine learning life cycle. All right. So now, in my machine learning life cycle, the first stage is data acquisition. Acquisition. All right. Now, if you've not watched my video on classification, please go and watch. That was where I took my time to explain each of these stages, but I will still go through it, but at top level. The next stage is data cleaning. And okay, the next stage is training data. Okay, and all right, I'll explain, guys. I'll explain. Testing data. All right. The next stage is model training and building. The next stage is model testing and bring this, guys. Okay. And the next stage is model evaluation. And finally, deployment. Right? Model deployment. All right. So we have specifically concerned about development. All right. So this is a basic life cycle for a supervised learning. All right. A life cycle for a supervised learning. Okay, great. Now let me start explaining. So data acquisition. First thing first, you must acquire the data. All right. It could be from any source. It could be from housing data, electricity consumption data, a health patient data, all right, etc. All right, it could be from anywhere. All right, so let's now do this from data acquisition. Right, we pull in the data into our environment. Then we now start performing what data cleaning using what pandas. Right, data cleaning using what pandas. Okay. Now, before you could use this, pandas to clean data, you must already know how to use pandas to manipulate data. All right, and which I did in this my series. There are this series, all right, pandas. So if you've not watched any of these series, please rush, go and watch it. I have from 1 to 6, all right, from 1 to 6. All right, mastering pandas. All right, data manipulation with what? With pandas data frame. Okay, that's it, guys. All right, please go and watch that. Now, after cleaning the data, I'm now going to split the data, right, into what? Into a training data set and a what? A testing data set. A training data set and a testing data set. Okay, so let me be coding along so that um the process will look very clearer. All right, let's code along. Let's code along. All right, so let me open my Jupyter notebook. Jupyter notebook. So since I will be using pandas, so I need to import my library. So I'll say import pandas as what? PD. All right. Now I also need to, I'll be using what? NumPy at some point. So also what? Import NumPy as what? MP. So similarly, I also have a video on NumPy in 60 minutes. Where's that guy? NumPy, this panda series. NumPy. So if you've not watched my video on NumPy, please go and do that. NumPy in 60 minutes. All right. Very, very important. NumPy in 60 minutes. All right. So let's go there. Okay. Then I'll run the cell. Okay. Great. Great, guys. The next on our list is we need to bring in the data. All right. Now, the data has been cleansed. All right. So let's import the data. So I'll now say what? My data frame is equal to as a variable, right? PD, right, as my pandas dot read underscore CSV. So my data is in the CSV format, right? So I'm going to read it. So my data is in my directory, right? So I'm going to run the cell. I've run the cell. So I've imported the data based on this data set. All right. I'll now split these data sets, right, in a kind of proportion, a training data and a testing data, right? This data that I just was imported, I'm going to split it, right? But before we do that, let's check the columns that we have in this data. So I'll say what? df, which is this variable, dot head, right? So head would display for me the first 5 rows of my data set, right? Ordinarily, I can come here and say just this. It displays the entire data frame in the data set. You can see. So I can also check information about the data set. It tells me that there are 3 columns, right? Total of what? 3 columns, all right? And there are total of what? 1,000 what? Rows, records. Okay, great. So I can also describe the data. So For rooms, I can get number of what? Rows. These are number of rows, 1000. The mean of the room is 2.6. The area is this. The mean area is that. And the mean price is that, right? Standard deviation, mean, 25 percentile, 50 percentile, 75 percentile, and the maximum record in this column. These are the values. All right? Great, guys. So let's go back to head, right? So similarly, tail gives me the last 5 records in the data set, right? Great. Head. Now look at now, I have 3 columns. I have the rooms, area, and price, right? I'm going to split this data set into what? Features and labels, right? Features and labels. So at this stage now, if we discussed this earlier, so features are the kind of cosmetics, right? It's likened to cosmetics that you apply to your what? To your data. Okay, so these are the features. The features are of this rental data set. So this is an information about this data set was gotten from this information was gotten from a kind of a rental or housing of data, right? Where we could see that there are a number of rooms, there are rooms as well as the area, the square foot area of those rooms. Based on the number of rooms and the square foot area of the rooms, a price was attached, right? Based on these features, all right, you're going to what? You're going to what? Price the apartment, right? You know what? Price the apartment, right? So now these are features. Rooms and areas are seen as features, while price is label. So price is what I will be predicting. I want to predict the price based on the number of rooms and the area, the square foot area of those rooms, right? I will predict what the price. So the price will be my label, while the rooms will be my what? My features. So I will divide these guys now. So my feature will be X, right? So now, right, will be what? Will be X. But before I do that, I can grab these columns using my data frames. I can say this, I'll say rooms and area. So you can see now I have been able to also grab these data frame. Sorry, these columns, and that's I've left out what? The price. Similarly, I can also just grab only the price. There we go. All right, there we go. All right, there we go. Great, guys. All right. So now what I would now do is I'll split it. My X is my feature. All right. So let me okay, let me be label. So here I can come here and say import your data sets. All right. So let's use the markdown for that. So I want you guys to understand this thing very well. Okay, great. Importing your data sets, this is what we do. All right. After importing data sets, now we now say, okay, divide your data sets into features and what? Label. Features and label, right? Let's mark down that, right? Into what? Features and label. So divide it, so X as my feature, all right? X as my feature. Okay, let's come here. Let's say X, all right, as my features, then Y as my what? Label. All right. So great. So I'll now say X is equal to DF of room rooms, comma, and what? An area. That's it. Then my y is, that's capital X. My y is df of price, right? I could use 1 or 2 as the case may be. All right. Now let's run that cell. So to run the cell, we execute the cell. Let's print out the value of x. So x is this, you can see, right? And y is this. Okay. I can add, sorry, can convert it to, all right. There we go. However, I am having extra column, which is this index, right? So this is not giving me just these numbers. I just need only these values. I don't need this extra column. Similarly, if I do the same thing with X, you can see now I'm having this extra column. So what I will do now, I will want to split off these index. I don't want this index. So what I will do is, please convert this into values, and I just need only the values, dot values, right? So once I do that, you should see that that pass should go off. That's converted it now into what? A typical array, right? We now have what? Only the values. You can see now, only the values. Similarly, for y, only the values. One dimensional what? Array. Okay, sorry, two-dimensional array. We have it now. Okay, great. Now that we have what? Divided our data set into features and labels, all right? Now, we need to now split the data, right? Split the data into what? A training data and a testing data, right? Split it into a percentage of, could be 80 for your training data and 20, right, for your what? Testing data. So now in machine learning, in developing machine learning model, what we normally do most times is we always split the data into a training data set and a testing what? Data set. All right. So we're going to assign a percentage to our training data set, and we're going to assign a percentage to our testing data set. So once we split our data based on into training and testing, right? The testing data, will be use the testing data to be testing what? Our model, right? Then we use the training data to train the model. We use the training data to train the model, while we use the testing data to test the trained model, all right? So now let's go there now. So now, to split the data, right, we'll be using what? A method. So I'm going to say from scikit-learn, sklearn dot what? Model underscore selection. Model underscore selection, right? From scikit-learn dot model underscore selection, import what? Train test, train splits, train splits, sorry, train test splits. All right. So train test split is a method used to what? To split, all right, to split what? Our data set. So let me, for proper understanding, let me also mark down this. So split your data set into a training and what? A testing data, right? A training set, a training and testing was set. So I will mark this down, right? So I'm going to run that. All right, great. So we've split it from this method, right? Do this, right? Now I also have another video I did on scikit-learn, scikit-learn. So if you've not watched this video, understanding scikit-learn, right? Understanding scikit-learn, right? I did justice on this video. Understanding what is scikit-learn is. So scikit-learn is a major machine learning library in Python, right? Used for training models, for doing a lot of things, all right, in machine learning. So from sklearn dot model selection, import what? Train test split. Now, what I will be doing now is I'll be splitting my what data sets, right? So let's go there. So I'll come now over here now. I'll now say x underscore train, comma, x underscore test. That's my train data set, my test data set, all right, for my features. Then for the labels, all right, y underscore train, comma, y underscore what? Test is equal to what? The function. I'll call the function train test split. Train, all right, train underscore test underscore what? Split. So it's a method, all right? So in this now, I'll be passing, wait, what is this now? Train test splits. So here I'll be passing my features, all right, my label, all right, and the percentage of my test data. So I'll say test size. Why am I'm coming? Did I run this? I run this now, all right. All right. So why is it not coming up? Okay. So let's look at the documentation. So right. So I'll be splitting this guy, my features, my label, and the test size. I'll say test underscore size. My test size is the amount of data I'll be allocating to my what? To my test data. The percentage I'll be allocating. So let's say I'm allocating something around 20%. I'll allocate 20% to my what? Test data. 20%. All right. Right. Then I'll now use the remaining what? 80% for my what? For my what? Training what? Data. Meaning that this data set, right? This data set you're seeing now, I'll split it into two on equal paths, where 20% goes toward the testing data, which I'll use to test the model, and 80% goes toward the training data, which I will use to train the model. All right. So I'll say the test size is what? 0.2, which is 20%, right? 0.20, right? Definitely to be 0.2, right? Great, 0.2. Then the random state, right? Because our data sets this random state is optional, right? But since we want our data sets to be shuffling, right? Shuffling, so we have to specify the random state. So I will say a random state of 42 or any number, guys. So this can be any number. You want your data set to be randomly, right, being shuffled at every interval. That's why we are using what? The random state, right? I hope I'm still recording. Great. Okay, great. At this phase now, we have what? Splitted our what? Our data sets, right? Now, this method is called, in Python, is what we call tuple unpacking. Tuple. This method is tuple unpacking. The tuple unpacking is a process, right? It's a process of assigning multiple values to multiple variables. Now, when you assign multiple values to multiple variables, what you're doing is what? Tuple what? Unpacking, right? So I'm going to execute that cell. I've executed the cell. So now if I say, what's my x underscore train value? I have this. You can see now, all right? X underscore test. I have the whole of this, right? This is my test data now, right? Great. Then I can say y as well. Y underscore train. I have that. Okay. Right. Then y underscore test. I have this. All right. That's it, guys. All right. Great. Let's continue. Let's go back to our what? Our data, our dashboard. So now we've split this guy now. All right. So now let's now train the model. Right. The next stage is what? Is to train the model. So let's go back to our Jupyter notebook. To train the model, train. But before we train the model, we have to instantiate your model, right? Instantiate the model. So instantiating the model, since we are using what this is simplified supervised learning, all right? So we're using what? Linear regression, right? So I'm now say from sklearn dot linear model, from this class, import this method. Import what? The linear regression method. All right. So that's the model we'll be using. Right. So okay, not instantiate yet. Okay, yeah, we are good. Right. So I'm going to run the cell. I'll run that cell. I've run the cell. Good. So now I'll now what? Instantiate. So instantiate, I'll say I'll create a variable called ML, load my model. So I'm loading the model, which is instantiating the model. I'm loading what? The model I will need to use to train my model, right? The algorithm I need to use. So I'll say what? LM equals to what? Linear regression. And I will execute that shell. I've instantiated the model. All right. Now, after that phase, I will need to what? Fit my model into my what? My training data set, which is this part now. I'm going to fit my what? Instantiated model. All right, great. So let's go there. I'll come over here and I'll say what? Let's do that now. Fitting your model into using the what? Training data, right? Using the training what? Data sets. The training data set that you what? You divided into 80%, right? We're now going to what? To fit them. And I'll say what? LM dot fit. Fit what? My X train and my Y what? My Y train. That's all. So I'll execute the shell. So I'll execute. So I've fitted my model, right? Right? Great. Now, based on this now, which means fitting your model, you've used the you've trained your model. All right? Great. Based on this now, all right, I can now make predictions based on my model instantiation, all right, my LM, all right, my load model variable, right. I will use this now to make what? Predictions. I will now come here, I'll say what? Let's which is that should be now we are at this stage now, model training, fitting the model, and what? I'm building the model. All right. Now, based on this now, I'll make predictions, right? I'll make predictions. Once I've made predictions, I'll now start what? Testing the model, right? All right, which is the next phase. The next phase now is model testing. So let's go back there. I'll come over here now and I'll say what? Predictions, right? Is equal to my load model, my instantiated model dot predict. So there's a class, there's a method in my loading model. So right. So I'm going to predict based on my test data. All right. So at this stage now, all right, which is prediction model testing. All right, let's come back here now. So I'll execute this shell. Once I execute this shell, there we go. Now let's check what's in our what? In our what? In our what predictions has this model made? Predictions. So once I run this, you can see these are the predictions so far. So based on this first record, right? Based on 2 rooms and 611 square feet area, they are predicting the price, right? The price that we have here is 975, the original price, and our predicted price is coming what as 1143. It means that for a room of 2 and a square feet area of 611, my predicted price from the original price would be what? Would be 1143, right? This could be more, all right? So at this stage, if my predicted price is almost times 2 of my original price, all right? So what will happen here is we'll now try to perform what we call fine tuning. Okay, so what will happen here is we'll try to what fine tune our model, right? Retrain our model, right? So let's this stage will be called tuning, model tuning, right? If the value doesn't make sense, all right, if there are more losses, right, there are more losses, or there are more gain, all right, there shouldn't be more gain, there shouldn't be more losses, right? It should be in between more gain and more losses. So that's what we call as overfitting and underfitting, all right? So once that happens, so you have to what fine tune your model to be in between, all right, to be perfect. Perfect means that it's in between overfitting and what underfitting, right? So fine tune the model, okay? But just for testing phase, all right? Let's just show us how it looks like, all right? So now let's now start using real values, all right, to predict our model. So let's clean this up. So what I'll now do is this. Let me hold this. I'll copy this. Sorry. All right. So I'll come over here. I'll now say, okay, for this now, I'll now say my predictions is equal to lm.predict. Now I'll say npi.array, npi.array. Now I'm going to pass the number of rooms and the square feet area. All right, I'll be using what numpy. So I'll say that my room is 2 and my what my square feet area is 611. Let's take this value, 2 rooms as against 611 as against area, all right? So what will be my predicted price? So I'll run that. Wait. Okay, come here. And yeah, what's our error even? Okay. All right. So now let's run our prediction as against the original prediction. So I'll say predictions. So if I run this now, I will see that, yeah, you can see now, based on what we had, all right? So you can see, based on number of rooms is 2, square feet area is 611. Our original price was what? 975, while our predicted price became what? 1099. So let's see the difference. So 1099 minus 975, 975. What's the difference? So there was an addition of $124 added towards 975. So it means that our model predicted that based on this data, right, and the price, the new price, right, the new price for our rental data set will be what? Will be 10,000. Sorry, I said 10,000. 1,099. 1,000 and what? and 99, right? So which is not too far, all right? Which is not too far, right? So now let's go there now. So you can see now we are now testing our model. So at this stage now, let me put this now. Testing your model. All right. At this stage, model testing. Let's mark this down, mark down, and there we go. All right. Model testing. All right. So based on our values, let's come in now. Let me add 5 rooms as against this number of area, square foot area, 3341. So my number of rooms is 5, and the square foot area is 3341. All right. So 3341. Let's run the model now. Run that. Let's check our prediction. Our predicted price is 6,283. What was the original size? The original value? 5,700 and what? 33. 5733. So 5733. Is that it? Okay. As against 6,238. 283, right? Let's check the difference. So the difference is an addition of what? 550 dollar, right? So you can see how we are, all right? We are now testing our model, all right? So if at this phase of model testing, right, based on our test data, look at now, right? We are using our test data, right? So the test data that was splitted, all right? So we're using the test data, right? Based on the test data, right? We are using the test data to want to test the model, okay? So which we're doing here. So if the output of our model is not making sense, that's when you now start performing what we call what? Model tuning. But if everything goes well, the next phase will now be evaluating the model, all right? Checking different errors, right? That's model performance, checking the performance of a model. So model evaluation is all about checking the performance of the model. And for linear regression, okay, there are 3 major metrics, right? 3 major metrics we use to evaluate the performance of our model. 3 major metrics. So the metrics are, at this stage now say evaluating the model, right? Evaluating the model, right? So in evaluating the model, there are 3 major evaluation performance we use, evaluation metrics. So the metrics are mean absolute error. So I also mentioned this in my series, which is um linear regression in machine learning. So regression in machine learning. So if you've not watched this video, guys, please head on to watch this video, right? Regression in what? In machine learning. So there I talked about the different evaluation metrics in detail on what? On regression. So the next is mean squared error. And finally, the third one is root mean squared error, right? So these are the 3 metrics, right? We could use, right, to what? To what? To measure, to evaluate our what? Our model. Okay, let's go there. Great. All right, guys. All right, perfect. Now, evaluating the metrics. So now say from sklearn, dot what? Dot metrics, sklearn dot metrics, import what? Import metrics. Import metrics. Import metrics from, what was I saying? What was I saying? Import. Sorry. Sorry, guys, please. So escalating dots. All right, so there shouldn't be any dot message. So if I'm using that, then I have to import. For instance, now let me show you something now. All right, in the class dot metrics. All right, there is no method called what metric. That's why we're having this error, right? So there are different methods. All right, so there's a mean square error. Right, so these are the methods you can have. There are mean absolute error, mean absolute percentage error, mean gamma deviance, mean pinball, mean Poisson deviance, mean squared error, mean squared log error. These are the different mean. All right, great, guys. Right, there's also root. Root means squared error, and root means squared error. So these are the methods in this class. So I don't want to import just few methods. I want to import all the methods. All right, I can import just this, comma, mean absolute, comma, then there's absolute score as well. Then mean what? Mean squared error, right? So I can decide to just import just only three methods in the class metrics. However, I don't want to do this. I don't want to do this. I want to import everything. So to do that, I'll remove this. I'll now say metrics. However, I need to remove the class from here. So this should clear our error. All right. So that has cleared our error. So we are good, guys, right? We're good. So from sklearn, import metrics. From sklearn, there's a method. There's a method from this class. There's a method called metrics. So I'm importing every other method in the metrics class. All right. I'm now coming and say what my mean absolute error, right? MAE. So my MAE, mean absolute error, right? My M absolute error equals to metrics dot mean absolute error. Can see now I'm calling the word method, right? So in my mean absolute error, I'm going to be passing my what? My test label, right? As against my what? My prediction, right? So if I check the method now, let's check the documents. So my y true as against my y predicted, right? Now these are the two parameters, most important parameters you have to pass. So your y true is our y test. All right, y test as against our what? Our predicted what value, our testing value as against our predicted value. So I'm using this to evaluate our model now. So I'll say what? My y underscore test as against my prediction. Now, what are we we've predicted? These are our prediction, right? So based on this now, we will calculate our what? Our mean absolute error. So let's see what the value will be. So run that. I'm having error. Okay, so all right, so let me do this. Let me comment this and let's bring up this, all right, as our prediction, right? So okay, let me change something. Let me say my y predicts. Let me just call it my prediction, right? Because we are performing based on the whole data, all right, on the whole data set. That's what on the whole data set we are performing, evaluating our model. All right, so there we go. All right, then we should come back here and run this. So this is perfect now. Now look at what I'm trying to explain now. We are the our evaluation is not just on just this data, just one data. We're evaluating the entire 20%. The entire 20% that we allocated, where's that part? Y test. The entire 20% that we allocated, well, that's my test size. from our data set. Right? That's what we are evaluating. Right? So that's why we got that error. Okay? So you can see now, our mean absolute error, the value is this. So to convert this into an array, I'll come over here, I'll say mp.array, right? Is a list, and that's there we go, right? So I've converted that into an array, not just the output giving me a numpy. So this is a what? A numpy array, right? Numpy array. So now this is our what? Mean root square. So let me so from our metrics, you should have mean absolute error. So our mean absolute error becomes that. These are mean absolute error. All right. So I can now say print, okay, the mean, all right, the mean absolute error is that dot value dot values. I just need only the value. Let's see if this will fly. All right, it didn't fly. It didn't fly. Right? It didn't fly. All right. So the mean absolute error is this. So I needed to shield off this guy. So let me see if I can shield it off. Put that and put that. It's not going off. All right. So if it's not going off, let's come here. Just need only the value. So this will be it's not coming. Not coming. We go an error. All right. All right. That's okay. All right. So our mean absolute error is this. All right. Now let's perform our mean squared error. So our mean squared error, let's mark this down. All right. So mean square error is going to be matrix dot mean squared error, right? So y test as against our predictions, right? So this we have mean square error, and the value is this, right? np dot float is this, right? So now I need to convert this to what? Using what? NumPy. np into a NumPy array, all right? NumPy array, we have that, and there we go. So we have it. So let me add some more. Print the mean squared error is that, right? So there we go. Okay, there we go. So let's add some effigy. All right, great guys. Then finally the root mean squared error. So finally we have root mean squared error. So our root mean squared error should give us something, right? So let's mark this down. Great. So root mean square error is equal to matrix, right? Dot root mean squared error of what? Of our y test as against our what? Predicted, right? Prediction. So root mean square error, we are having this, right? So our root mean square error is this, all right? Great. So similarly, we could do something different. We can say our root mean square error, our root mean square error. We use a different method, right? okay, let me say RMS is equal to, all right, non-pi dot square root of what? Square root of your what? Of your matrix, right? Dot mean squared error, mean squared error, right? Because it is this squared error that we are squaring. We are taking the root, right? We're taking the root of our mean square. Look at it now. MSC, MSC. That's the mean square error. So we are taking the root, all right, of your what? Mean squared error, the square root. So you can take the function, all right, the numpy function, and apply it to our mean squared error, right? Mean squared error of of our what? Of our y test against our what? Predictions. Good. So our RMS gives us same value, guys. Same value and same value. You can see. Similarly, another method, you can see RM equals NP dot square root of MSE. All right, square root of MSC. RM, same value, guys. You can see. So different methods. I'm getting what? Same result, right? So let's just stick to this, guys. So I'll now say what? Print the what? The root mean squared error is, all right, is that. Okay, there we go. I can delete this cell, delete that cell, delete that cell. So this is everything about evaluating the model, right? So you can see we've now evaluated our model. You can see that we have 580 as root mean square. The mean squared error is this, and the absolute error is this. So these are ways you can evaluate your linear regression, right? Linear regression, right? Then the last but not the least, so that was model evaluation. The last but not the least will now be what? Model deployment. All right. So you can see how we've been able to what? To fit in to program, okay, all right, each of our machine learning life cycle. All right, you can see how we've been able to what? To convert these stages, right? The stages in our machine learning life cycle into a pure Python code, right? We've coded each of these stages, each of this level, right? Each of these stages, all right, into a what? A pure Python code. So this is it, guys. This is everything about developing what? A model. So right. So what we've used so far is the model that we've used is what? Is linear regression, right? That's why I see we imported it somewhere here, right? Linear what? Linear regression. The algorithm we've used, all right, is linear regression. So we've used that algorithm to deploy, all right, or train or develop or to develop our model. So that being said, guys, I hope this session has been very, very educative, all right? And I hope to see you guys in our next episode. Thank you and have a wonderful weekend. Thank you.